41,782 miles of gravel road in Arkansas. That's 51.75% of all the roads in Arkansas, which is why gravel roads are so important. This video will discuss the components of a good gravel road and the procedures for maintaining them.
First, let's look at the various components of a roadway. A typical roadway consists of a wearing surface, a shoulder, and a ditch. The wearing surface must be sloped to drain water away from the surface. Standing water on the wearing surface will soften the road and traffic will create ruts. A slope of 1/2 inch per foot from the center or crown of the road is recommended. This slope means the road will drop 5 inches in a 10-foot wide lane. The most desirable crown is shaped like the letter A. In other words, a straight, sloped line from the center of the road down to the edge of the shoulder. The shoulder is the section within the roadbed between the wearing surface and the ditch. Although desirable, it does not require an aggregate base like the wearing surface. The shoulder provides space for emergency use and drainage for the wearing surface. It must meet the wearing surface at the edge of the road and slope to the ditch at the same slope as the wearing surface, or at a greater slope. The third and perhaps most important part of a roadway is the ditch. A wise engineer once said, "There are 3 important things to remember about the maintenance of a gravel road. They are drainage, drainage, and drainage." Standing water in a gravel roadway will soften the wearing surface and subgrade, making a quagmire of the road. The ditch carries water away from the roadway and has both a foreslope and a backslope. The foreslope must be greater than the slope of the shoulder. 2 horizontal to 1 vertical is typical. The backslope can be even steeper if clay is part of the subgrade. In any case, the ditch bottom should be well below the crown of the wearing surface. 2 to 3 feet below is normal. Now that we know the basic components of a roadway, let's take a look at the most widely used part of a gravel road, the wearing surface. Gravel roads use a wearing surface that is a blend of different size aggregates: coarse aggregate or gravel, sand, and fines. When the blend is right, the smaller particles fill the gaps between the larger gravel to make a blend that will be compacted by traffic into a strong, tight wearing surface. The recommended blend of aggregates for an ideal wearing surface are gravel, 35 to 80% by weight, sand, 15 to 40% by weight, fines, 5 to 25% by weight. Fines are a mixture of clay and silt that should have enough plasticity to bind the sand and gravel together. The liquid limit of fines should not exceed 35, or the road will become very soft during long periods of wet weather. Liquid limit is the water content where the material becomes more liquid than solid. The ratio of fines to sand and fines combined should not exceed 2/3. For a more in-depth look at the composition of the wearing surface, let's join Dr. Sam Thornton at the University of Arkansas, Fayetteville.
This is Sam Thornton in the Soils Laboratory of the Civil Engineering Department at the University of Arkansas in Fayetteville. What we've done is taken a sample of SB2 aggregate or Class 7 aggregate, which the Arkansas Highway Department uses for construction of roads in Arkansas. And I have placed them in the sieves and separated them according to size. In the first set of sieves, which I have here, are the gravel material. This material is material which is retained on the number 4 sieve. A number 4 sieve is a sieve which has 4 wires per inch in each direction. I'll show you these sieves in just a moment. This coarse material, I'll take a sample of it, show you can see, is all gravel size. And if we take material of this size, and then the next size material is the material which is on the number 40 sieve. And as you can see, that material is finer, but is still coarse. And this material would fall into the into the sand and fine gravel category. The next size sieve is the number 200 sieve. As you can see, this material is much finer, but even material retained on this size sieve is considered to be sand in size, but fine sand. Finally, the last material is the material which is retained in the pan. Now, this material is very fine and very soft, very smooth. If you put this material, for instance, in your mouth and bite it and wiggle your teeth back and forth, it would be smooth. Now, when we blend these particles together, we have the SB2 mix. I'm going to do that now. At this time, I'm going to show you the sieves. This is the number 4 sieve, which has 4 wires per inch, and so that means that any particle which passes that has to pass through one of these holes. Next, we have the finer material, which you can see is relatively coarse in nature, but a little more coarse, say, than sand, but fine as a gravel. Next, I'm going to place the sand-sized material, which is even finer, into the pan. Finally, I'm going to place what we call the fines, which is silt and clay, in, and you can see there's not very much of this material in the SB2 mix. SB2 specifications allow up to approximately 8% fines maximum, but it can go down to 0. And in this particular sample, there are very, very few fines. Now, one of the things which I wanted to show in this mixture is that this material, as good as the material is not a real good wearing course for a gravel road. And the reason it's not is because it does not have enough fines. I'm mixing the material now. So that I can get it all non-segregated and mixed together. And I'll spread it at this time. Now I'm going to add water to the aggregate to show you what it would do if it were on a roadway. The point of this demonstration is to show that even with the water added, it's still a granular material. It does not compact into a ball, and therefore will not set up to be a cohesive wearing surface. And so what this particular material still needs at this point is more fines. What I have here is a sample of bank run gravel, which was taken from a hillside near here. And it has considerable amount of fines in it with the right kind of plasticity. And so what I'm going to do is to mix some of the fines in and to show you what the effect is. When the material is finely mixed, you can see that if you put it together to make a ball, it makes a good cohesive mix. Now, when this is compacted and dried, it will make a fine wearing course. All of the coarse aggregates will be stuck together. And this is what you want. You want not just gravel, which can be washed away with rain and the action of the people's tires and thrown to the side of the road. You want it to set up and make a strong, cohesive wearing surface.
Gravel roads are constructed of loose aggregate bonded together with a mixture of sand and fines compacted by traffic. With normal wear, the surface of a gravel roadway becomes unbonded and rough. When this condition occurs, the roadway needs to be smoothed. Smoothing might best be described as the redistribution of the loosened aggregate back onto the roadway. As we discuss the recommended procedures for smoothing, Keep in mind that the terrain of Arkansas will present many different situations. Use safety and common sense in all situations, regardless of conditions. Before beginning any maintenance operation, mark the limits of the area in which you will be working and place the proper traffic warning signs. Ensure that all warning lights on your equipment are in proper working order. For more detailed information on signs and safety, consult Part 6 of the Manual on Uniform Traffic Control Devices, or see your local area supervisor. Before beginning the smoothing operation, check the drainage conditions on the section of roadway about to be smoothed. Aggregate tends to wash into the ditches during heavy rains and must be removed for proper drainage. To remove aggregate from the existing ditch, swing the blade carriage over to the pull side as far as possible and angle the blade to approximately 45 degrees. The aggregate should be graded up onto the shoulder area into a windrow. If any excess material is present in the culverts or drainage pipes, it must be removed by hand. Improperly cleared culverts act as dams, allowing aggregate to build up and flooding of the roadway to occur. Drainage is the most important factor in maintaining a gravel road. Once the ditch has been cleared, the material must be windrowed into the center of the roadway. Recenter the grader blade and angle it slightly to the rear. Raise the end of the blade nearest the center of the road to ensure that you blade the proper amount of crown on the surface of the roadway. Care should be taken to control the speed of the grader. Too high a speed will cause a washboarding effect on the surface. Move the material evenly into the center of the road without cutting too deeply. Use only enough pressure on the blade to drag the excess material across the surface of the road. Once the aggregate has been windrowed into the center of the roadway, it is ready to be smoothed. If your grader is equipped with a crown gauge, use it to set the proper blade angle. If not, set the blade so that the end near the center of the road is approximately 5 inches higher than the end of the blade at the shoulder. With the blade set properly, smooth the roadway. A properly set blade will create a dragging, rolling action that will compact the surface as it is bladed. For most roads, a single round will be sufficient. If there is excess material in the center of the road, another pass will have to be made. Spread this material evenly, being careful not to destroy the crown of the road. When the aggregate and fines have been mixed and spread evenly over the roadway, the smoothing operation is complete. Traffic will compact the mix into a safe, smooth riding surface. Although not recommended, a windrow may be left at the side of the road. If windrows are left, cuts must be made at short intervals to allow runoff water to drain away from the surface of the roadway. Windrows left at the edge of the road act as curbs and can form secondary ditches, washing out low points in the road. Ideally, gravel roads should be smoothed when the aggregate and fines are moist. If smoothing has to be done in dry weather, the use of a water truck is recommended. Now let's review the steps involved in smoothing a gravel road. First, define the work limits and set the proper warning signs. Next, remove any excess aggregate from existing drainage ditches. Clear the culverts by hand if necessary. Windrow the excess aggregate up onto the roadway and smooth the roadway with a proper crown. Time and traffic take their toll on gravel roads. Heavy use scatters the aggregate, flattening the crown. Potholes and ruts appear in the road, along with deep ridges that can turn the road into a virtual washboard. These conditions cannot be corrected by smoothing alone. The surface must be reshaped. In reshaping, the crust that forms what is left of the old wearing surface must be broken up and the aggregate base remixed to get a proper blend of fines and base material. This process oftentimes involves the use of a scarifier, but new material may need to be added, particularly in extremely rough or washed out places. Before we discuss the recommended procedure for reshaping, let's first review the basic components of a gravel roadway. A typical roadway cross-section consists of a wearing surface, shoulder, and a ditch. The wearing surface must have a crown or slope to allow water to drain away from the surface of the roadway. Roads that need to be reshaped often have very little or no crown. In any case, the reshaping operation must rebuild the proper crown on the wearing surface. To determine the proper crown on the road, use the formula where the road slopes 1/2 inch per foot from the center or the crown. This means that the slope of the road will drop 5 inches in a 10-foot wide lane. Now let's look at the reshaping operation. First, mark the limits of the operation area and place the proper warning signs. Ensure that all warning lights on equipment are in good working order and that no traffic hazards exist. Check Part 6 of the Manual on Uniform Traffic Control Devices if you have any further questions. Next, check the condition of the roadway. If it is soft, the road may be reshaped by first putting the grader blade in the cutting position. The bottom edge of the blade should be in front of the top, and the blade should be angled 30 to 45 degrees. This provides a mixing action as the aggregate rolls along the blade toward the center of the road. Tilt the front wheels 10 or 15 degrees in the same direction the material is moving, and be sure to shift the blade so that the windrow is placed inside or outside of the grader wheels. Watch the blading action very closely, adjusting the controls to ensure that the blade cuts deep enough to remove any rough shoulders or washboard ridges. More than one pass may be required to cut down to the bottom of potholes or ridges. The aggregate should be windrowed into the center of the roadway before reshaping the road. If the surface is too hard to blade easily or the trouble spots too deep, scarifying is necessary. The main point to remember in scarifying operations is to cut only as deep as necessary, usually only 2 or 3 inches. The scarifier should cut to the bottom of the pothole or ridge, leaving as much existing crust as possible. Once the area has been scarified, the material should be remixed in the same manner as reshaping. Scarifying can be effectively used to reshape small sections of roads that may otherwise need only smoothing. When the aggregate has been remixed and windrowed, the road is ready to be reshaped. Set the angle of the blade forward to provide a compacting action and spread the aggregate evenly from the center to form a proper cross slope. Ensure the proper cross slope or crown by using a crown gauge, camber board, or any other means available to get the proper angle of taper you want for your road. Blade the shoulder downward to the ditch at an angle at least equal to that of the wearing surface, taking care not to leave any excess material on the side of the road that would inhibit proper drainage. Once the roadway has been properly reshaped, the wearing surface must be compacted. The use of a rubber-tired roller, grid roller, or water truck is recommended. Traffic will also compact the roadway, but a rubber-tired roller is considered best. Whatever means of compacting are used, make sure that you do not destroy the crown of the road by making passes down the center line. One of the most common problems experienced in reshaping or smoothing gravel roads in Arkansas is the presence of large rocks in the subgrade. Removing this unwanted material is expensive and at times impractical. An alternate method of dealing with this problem has been devised by Charles A. Johnson and the Washington County Highway Department. This method involves the use of a grid roller constructed by modifying a self-powered earth-moving machine. Using concrete weights and a heavy steel grid roller, this machine is driven over the windrowed aggregate, effectively reducing many of the large rocks to usable subgrade material. The crushed aggregate can then be remixed with the underlying fines and gravel and reshaped into a cohesive wearing surface. For further information on the steel grid roller, you may contact Jim Brink at the Washington County Highway Department, 2235 North Gregg, Fayetteville, Arkansas, 72703. Over 51% of the road surfaces in Arkansas are gravel covered. A properly maintained gravel road is a safe, economical means of serving the thousands of Arkansans who depend on these roads and you for access to their homes, farms, and businesses.